Yep. Hi, everyone. My name is Vijay. I'm super excited to share some of our key technologies for, representing here to as well as research guy, and sharing some key technologies in future of making in construction. I'm a part of a research team under CTO's organization and based in Singapore. More than 600 employees in Singapore with 300 more than over 300 research engineer developing various solutions and softwares for future customers. So in total, we have more than 11,000 employees worldwide and 18 million active users. If you're familiar with Autodesk, we make software tools that helps customers design and make anything from high-rise building to building components to bridges and blockbuster games. 38 years ago, we started with just one product called AutoCAD and start creating software tools to help people with the design challenges every day. We have been innovative since ever. In early 2000s, we introduced 3D modeling and BIM-based design. Today, we are developing tools for cloud-based BIM process, or we called Autodesk Construction Cloud. Our AC customer use these tools to collaborate better and visualize, manage their data from the office to the field. And we are thinking about tomorrow by researching and developing the disruptive technologies and process that will change the landscape of future. So what does it will take to build something better? What is the technology's key role? So in order to adapt the new technologies, we have to think of three things. So if you want to do something, you need something to build first, or you need to have smart things, or you need to have a process or making, or you need a changing way to work. So I'm going to talk more on the making side. So when I talk about the process of making and how it will be different, we're talking about ideas and practice from another Autodesk support industry like manufacturing to increase the productivity and efficiency in the design and construction process. Industry one using traditional method to design and build the future. So what we have to do is we have to think out of the box. So instead of we'll be relying increasingly on prefabrication, building a factory before we get the job site to assemble our project. And the key thing is we had to rely on these kind of instruments, and there will be many different variants. So robot will be a broader, more significant role too in this region. So helping construction teams to solve skill labor gap and build faster using these kind of robotic solutions. So this will make more dangerous tasks. This will take our more dangerous tasks to protect the safety of construction workers. The means of production will also change. The advance of the technology like 3D printing and IoT will help to monitor the track activity on the job site to boost the productivity. So I want to show some of the key technologies here, especially on the manufacturing of an assembly. and 3D printing in robotics. When we talk about the process of making, how could it be different? We're talking about using ideas and practice from another Autodesk support. The uh, the industry, no, a growing population will require construction industry to do more with less waste of adopting robotic automation components for constructing should design for automation, autonomous vehicle, additive manufacturing, and other types of robotics and automation are beginning to impact construction site. This is an example, a fast break robotics from Australia. They lay real bricks. In order to do that, they have to uh, know the building information, and they have to do a geolocation with the actual CAD model as well as the robot itself. So they use Autodesk Forge platform to create automated applications and process by connecting various different softwares within the of Autodesk itself. This is another example. It's a company called Scansa. It's a robotic drilling company used in construction. They use a Nova's Lynx robotic drilling machine on this project. So they claim it's a first mobile robotic drilling machine, and it's 8 times faster than the manual worker. The robot is geolocated again and connected with the building information model. The BIM is what the robot, so it can drill the holes for installation of MEP systems with some millimeter accuracy. They use a BIM and BIM 360 and Forge platform to feed the data to the robot to put the laser marker and automate the drilling operations. This is a company in Singapore. It's a woodworking company. They use manufacturing tools and technologies, a carpenter using to build the resorts around this region. So they use Autodesk Power Mill manufacturing software to generate offline cutting path to run their ABB industrial arm to cut size. So Autodesk helped them to automate the entire robotic programming process to eliminate mistakes and increase the productivity. Using our support, the company invented new type of reinforced fire retardant sustainable wood, which they branded as One Wood. So you can see all these robotic. We can do tool change to we can change the tools according to the feature of the wood or the shape of the wood. This idea is from, again, a manufacturing industry, and this is done with additive manufacturing. So we call it as 3D printing. So a lot of potential 3D printing to reduce the waste of AEC industry by allowing firms to only produce what they need. Autodesk worked with this firm called X to streamline the process of 3D printing with information from building from BIM models. You can see the X-ray is printing a drainage pit. So 3D printing allowed to save the cost and creating cost of to save the expensive framework of the concrete. So by this we can remove avoid the eliminate the waste of the process as well. We gave our EC side expertise to design the bit. We provide the software solutions as well as the manufacturing solutions to slice it and run through the robotic simulation and print it. This is another idea is demonstrating a 3D printing expansion form. They pour concrete into the expansion form mold to demonstrate the printing capabilities. So this is done in France with a collaborate with the university. We started design from nozzle itself using our safety simulation analysis tool to design a good nozzle. Then we bring that design into our manufacturing solutions to generate the slice and path. The robot path and speed we controlled in such a way that the form is fully expanded when the next layer is printed on top of it. So we make sure everything is cured or expanded properly before the next level reach. So we also have a digital twin capabilities also. So you can add reinforcement or whatever within the expansion within the mold itself. In this, another idea of sustainable housing habitat in deep space using additive manufacturing for NASA. This was a competition, and we worked with the AI Space Factory on this project. Was an attractive endeavor because the construction technology developed for use on the moon and Mars could provide valuable benefits here in Earth, like low cost housing solutions using recyclable or locally sourced material. So in this project, we have to work with the material aspects as well, 3D printing technology, and the characterization of the materials. Yeah, and I'm showing this video.
Roger, go for deploy. The idea of colonizing another world has always been a fantasy of ours. It is in our nature to pioneer new lands, to settle and inhabit even the most unforgiving environments. If NASA's astronauts are to have a long-term presence on the moon or on Mars, they'll need to figure out ways to build habitable structures, something that will protect them from the extreme temperatures, radiation, and micrometeorites. NASA's engineers face a major challenge. Shipping large quantities of cement or other heavy building materials aboard a rocket just isn't practical or cost effective. Engineers at NASA's SwampWorks are developing a solution: 3D printing habitats on other planets using natural resources found on site on the planet's surface.
Along the way, we discovered that what they are doing, and then we realized how this could be utilized for the industrial construction, how we can build the sustainable structures.
Using new additive manufacturing technology Combined with the latest advancements in material science, structures can be sustainably built using a combination of local materials and lightweight recycled materials. By mixing small amounts of plastic waste with lunar or Martian regolith, similar to dirt and rock found in desert climates on Earth, a cement-like structure is formed and composited into place with robotic precision.
We are using Fusion 360 for the design, PowerShape for the redesign, and PowerMill for the toolpath generation.
The technology that we're seeing today is incredibly valuable because it's using automation in order to produce that. So that means that I can repeat the process in even the most remote area of this planet.
The materials and techniques being developed on this project have the potential to revolutionize the way we do construction here on Earth, too. Plastic pollution could be recycled to sustainable 3D printed streets, sidewalks, playgrounds, even habitable structures.
This is really the future of making things, is how we reimagine designing for manufacturing. So now we need to rethink how we design and manufacture parts by joining these two skills in one.
We have the opportunity to advance them together in order to reach new frontier, either to impact the life here, but as well the life in the moon, in Mars.
Ignition sequence start. 3, 2.
Yep. With that, yep, that's it. Thank you so much. Let me stop sharing.
All right, thanks, Vijay, for the presentation.
Yeah.
Okay, so so maybe we just start with the questions from the audience.
Let's invite Henrik back and
Yeah, Henrik's here. Yeah.
Yeah.
I'm here.
We will just have a well, kind of